Hello, AP Physics Lab students. This is Dr. Bennett, and here is another really cool virtual physics lab, and it's called Friction Lab. And as you see by the description, what it says, this lab will let you determine the coefficients of static friction and kinetic friction between different surfaces. We will be pulling with an increasing tension until the object begins to slide, and then you'll keep the object moving at a steady, slow and steady speed. And it will provide a graph showing you the tension in the string. Okay, so here's the link at the top. Okay, I'll of course send that to you within a remind, and you'll be able to get to this simulation. So let's show you what it looks like. Okay, I'm going to click on the begin. Okay, so this is the page that it will bring you to. Okay, so I'm going to describe it, and then I'll go into what you need to record and what you need to be mindful of. Okay, so here is a virtual image of what this is, which is the force transducer. This person is holding this force transducer, basically tension, and it will record how much force you have to apply to get this object to move. So here's several things about this simulation. You have several things you can change. The types of surfaces. So this will be glass on glass. You see it's kind of translucent there. Glass on glass, graphite on graphite. So basically these are two surfaces of the same type that are rubbing against each other. Wood on just a regular lab table, okay, rubber on ice, aluminum on steel. So each of these will have different interactions because the surfaces are different. So we're trying to get some essence, some meaning behind the different types of surfaces and their relative roughness as we slide objects on top of them. Okay, so you can have options to do that. Your task will be to choose two different surfaces. It doesn't matter which two you use, but on your data table, you need to tell me what surfaces you are using. Second thing, the mass. You can vary, and as you can see, the mass here will either get bigger or smaller depending on how much mass you're adding. There is a max value there, but you will actually do this virtual experiment 10 times using 10 different increases in mass, okay, because we want to get some really good data. And the cool thing is you just press a button and that will give you your changing mass. So if we start, with a low value, okay, and we're going to pull on this thing, okay, so I'm going to press start in a second, but below here it's an empty space, but it's going to generate a graph for you of what's physically going on here. So let me just press the start button and see increasing force. So that indicates you are trying to pull this object. Then it will create this graph here. Look at that. Isn't that cool? So what this is doing is virtually giving you a digital output of two things. Well, it's increasing time, so as time is moving on, you are, and see the y-axis here, we have the force, very small, 0.1, 0.2, all right? So you are applying a force over time, increasing, and then it reaches a max value, and then it stabilizes, okay? So your task will be to record in each of the simulations the max force, and this looks like it's maybe 0.18 perhaps, and then this value here, which may be 0.14 perhaps, okay? So you are going to record both of these numbers on your data table, okay? So let me reset, see, click that, and I'm going to increase the mass, okay? I'm just going to go really high, but of course you increment up 10 different masses, okay? Record your mass and everything. So here we go. I'm going to start this thing again, okay? And look, this graph is generated. Look at that. Isn't that amazing? And this is literally how it will look in a real lab situation. So now you look at the graph and say, wow, this force in my tension that I'm pulling, this max force is about maybe 1.6. All right, and here's, yeah, 1.6, 1.55 looks like. And then this one, the one that's stable here, is maybe, 1.25 perhaps. Okay, so you record those two values, all right? So that's the gist of how you're going to actually get your data. You're going to record the type of surface, your mass values as they increase, and then these two numbers, okay, the forces that you're actually feeling and measuring with the tension in this string with the force transducer, okay? All right, so let me go back well, actually, let me show you the data table that you need to create within your lab book. Okay, so you record your surfaces, your mass, but make sure you convert that into kilograms. See right there? All right, kilograms, the normal force, the max friction force, and the one that's constant. Remember the one that says, oh, it's stabilizing now. Okay, the normal force, you know how to get that right. mg. So the heavier the object, as you saw, actually our normal force will actually change. Okay, so that's what you're recording each time, and I'll come back to this to show you what type of graph you're going to actually generate. Okay, I just have kind of this graph paper here, but you will definitely see what you need to graph. Okay, so getting back to this, and so let's get back into really the essence of what we have here. So let's look at our free body diagram. All right, so I'll send you, of course, both of these links, but let's see what's going on if we were to unpack what forces are going on. So we have our mass. This represents our mass. This is the table of whatever surface we're pulling it on. And we have a friction force that's, of course, acting in a direction opposite of our pulling force. You see the force probe, which is like our tension force, our applied force. They're kind of lumping all that together. But the fact of the matter is there's some type of pulling force, and we're just trying to quantify how much force is needed for us to overcome the friction that is there between the two surfaces so that we can make it move. Okay, and we have our gravitational force, and of course this is not how we draw our normal force. It should come from the center on out, but the fact they're just trying to show us some interaction between the table and the mass. Okay, so check this out. Okay, so in our case for this situation, again, this is not always true, but the gravitational force is equal to the normal force because they are equal and opposite. They are the only forces in that y direction, so they're balanced. So if we know the gravitational force, we know the normal force because they're equal to one another. Okay, equal in magnitude, opposite in direction. Okay, and then we have this FA is equal to the friction force. Now let's see if we can unpack that. So X direction that we're considering here, the applied force, the tension force, they unfortunately kind of lumped all that together, but it's still some pulling force. So we have the applied force, and the only other force in the X direction is the frictional force. So those are equal and opposite, and they balance each other. So if we know one, we know the other, and vice versa. If we have to know the friction force, we will know how much we were pulling on this object. Okay, so I'm going to scroll down a little bit. Here's a little bit of info. Okay, all right, but we will focus on part 1 only, which is the virtual. Part 2, to scroll down, is the actual. If we had the all the equipment there, we just don't have the force transducer, we have everything else. But this is really good because it gives you everything you need. Okay, so again, in the instructions, this outlines exactly what I was saying in the previous screen with the actual simulation. So it steps you through what you need to do. Okay, and of course it will produce this really great graph, okay, where you're going to get the stabilized number and the max number. Okay, all right, so again, use 10 different masses throughout the course of the experiment. Okay, all right. Okay, and it says record the force. We're going to record two, the max force and also the stabilized force. And this is what you're going to graph. Force, the friction versus the normal force. Now which one should be your independent variable and which one should be your dependent variable? Which one do we control and which one do we just measure and see what happens? Okay, that's the difference, right? So that's what you're going to do. Let me go back to the simulation here. Okay, let's begin there. And you're going to again record your surface and record the masses as well as the max. Oh, you know, it's going to generate the graph, the max and the stabilized value. Okay, so let's go back over to the data. Okay, so I kind of give it away here. I show you what the independent variable is, the normal force. We're increasing the mass. We're increasing the mass. So on the x-axis, that will be our normal force. And then we see what happens. And the friction force depends on whatever normal force or heavy mass, as we increase the mass, what friction force is there. Okay. Would it make sense that the normal force, as the normal force increases, the friction force will increase? Okay, your data will show you what happens. Okay, so on each graph, you're just going to generate two graphs here. Okay, one for each surface. Okay, so you're going to put your normal force increasing, right? All right, on the x-axis, and then on the y-axis, you're actually going to plot two values. That maximum friction force I told you about, and also the stabilized or constant friction force. So you're going to have two lines on each graph. Okay, so you'll have two slopes that you need to find on each graph. Okay. Now what do we do with that stuff? All right. Here we have our discussion questions, and it will help you to figure out what in the world we just found. Okay. All right, discussion questions. Number one, after finding the slopes of each line, there you go. That kind of gives you an idea of what the shape will be. So find the slope of each line from your graph, and it says you will find two slopes from each graph. Provide a discussion of the meaning of the slope. Like, what is that slope? What is that slope? I mean, what number is that? What are you talking about? So you're going to find the slope, and you know, like, what is it? Number two, what is the unit of the slope, right? The rise over the run, and that will give you the unit. Okay, so take a look at what unit you'll get after you find the slope, right? So number three, what is the meaning of the magnitude of the slope? So you're going to have two lines. Will those slopes be the same number? In other words, again, the magnitude, the amount. Why is it different depending on the surface? Or is it different depending on the surface? Okay, so you're going to get two different, you know, surfaces that you're going to pick, any two that you want. And tell me, why is it different? And you're going to answer, just have all of this in your lab book and just provide, you know, all the information there. There's no need to put it on separate paper. So make sure you put everything there and we will see what you get. Okay, so hopefully this has been clear. Let me know if you have any questions, but have fun with this, and you know, we'll see what information we can glean from this. All right, thank you very much, students. Have a great day.